Hey everyone, this is Austin Hoggett here to give you another lecture from OpenStax Elementary Algebra. Today we're going to talk about sections 1.5 and 1.6 dealing with fractions and their four basic operations. We'll start our discussion here on giving a basic definition of the fraction, talking about equivalent fractions and how those are helpful in other calculations. How do we simplify fractions? And then we'll delve into the operations that we need to talk about for today. So our first topic here, finding equivalent fractions. Again, let's start with a basic definition. So the notation here shows that a fraction is typically written as this form a over b, the stipulation being that b cannot be equal to 0, right? So division by 0 in mathematics we say is undefined, and so we had to put that sort of limitation on our definition. So we call a, whatever expression may be, it could be a number, it could be some sort of variable. We say that a is the numerator and b is the denominator value, where the fraction represents, if you could think analogously to, let's say, a pizza, some part of a whole physical object, be it a pizza, cookie, anything you want. And the denominator value here, conceptually speaking, represents some number of equal parts that that whole physical thing has been divided into. So that's sort of a key criteria to the definition here. So given the two images here, we could say that, for instance, on the left, the shaded regions of this object could be representative of the fraction, let's say 3 out of 3, where the top number here represents the number of shaded regions out of the total, right? The bottom number also being 3, right? And this calls to mind the property of 1 that we see down here. Something like constants over themselves is always going to be equal to 1 as long as the constant is not 0. So for instance, 0 divided by itself, again, is sort of a controversy. And the other image that you see here, we actually only have 2 out of the 3 shaded regions being represented. So we could say that 2 out of 3 would be how I would describe this as a fraction, as a proportion of the shaded region to the total, right? So that's how we can write a fraction. Now let's talk about equivalent fractions, because there's actually several different ways to make the claims that we just did. As you see here in my example, I have the same exact pizza, but I've got it divided into two different equal parts. In the first part, we show a whole pizza divided into 1/2, two equal parts rather, where one of the halves has been eaten, apparently. So an equivalent way to demonstrate this is to start with a same size pizza, but instead of cutting it into 2 equal parts, we cut it into 8 equal parts. And if I still eat half of that pizza, I could describe this as having 4 out of the 8 slices remaining, as opposed to before having 1 out of the 2 pieces remaining. So these are our equivalent fractions. So the question becomes, how do we get from one state to another? Well, the equivalent fractions property shows us how this is done. If we start with some initial fraction, a over b, an equivalent fraction means that I just simply multiply some constant term by the numerator and denominator. So you see several examples of how we could slice this pizza differently in the bottom corner here. So for instance, if I had wanted the pizza to be cut into 4 different slices, right? An equivalent to still having only 1/2 of the pizza remaining would mean that I would have 2 out of the 4 slices remaining. And we actually calculate this by, again, multiplying our original fraction 1/2 by some constant term, in this case 2 over 2, right? So the constant term over itself, in essence, is a way to multiply our initial fraction, a over b, times 1. And we know that some fraction or even any integer value multiplied by 1 is just going to give us back that same fraction. And so we use this equivalent fractions property to change the look of a fraction without changing its value. And that's very useful in several different types of computations. And as well, we use this process sort of in reverse to simplify fractions. So let's take a look at how that's done. But first, let's talk about finding equivalent fractions for some example like 2/5. And I'll do this quickly. If we have the fraction 2/5, again, I just want to figure out what is some constant term I can use to create an equivalent fraction, right? Now, it helps to have a denominator in mind for what would be the result, right? So let's say, for example, here, I want to have a denominator of 10 as the result. How do I get from a denominator of 5 to a denominator of 10? Well, I would have to multiply 5 by 2 to get 10. And so to do that more precisely, I've got to actually multiply both values by 2, numerator and denominator, such that I'm only really multiplying the initial fraction by 1. Without changing the value, I just change the look. So 5 times 2 is 10, 2 times 2 gives me 4, and now I've created an equivalent fraction to my original. Now, as you can see, I could basically arbitrarily choose any constant term and come up with a new looking fraction. So in this case, I choose 3, I get 6 out of 15. And the last one here, we could say arbitrarily, let's do something like 2 times 10 and 5 times 10. We would end up with 20 over 50. So again, all of these fractions are equivalent, but they look different from one another. And what I mentioned at the top here was that we use these equivalent fractions to actually reduce our terms, right? So what does it mean to simplify a fraction? Well, let's take a look at our examples for that. So to simplify a fraction, we have to claim that there are no longer any common factors in the numerator and denominator. So my two examples here are 2/3 and 10/15. We would say that 2/3 is simplified because there are no common factors for 2 and 3. But 10/15 is not simplified because I could come up with a common factor between the two. So I could rewrite 10/15 using this equivalent fractions property in reverse. So 10 could be restated as 2 times 5, and 15 could be restated as 3 times 5. So notice, based on our pattern here, that the common factor 5 shows up in both cases. And 5 divided by 5 is going to give me 1. 1 divided by, or excuse me, multiplied by the remaining factors 2/3 leaves me with the simplified fraction that I would desire. So that's how we actually use the equivalent property in reverse, right? It's not always so obvious what the common factors are. So it helps to have, for instance, a calculator handy, or just have the skill set of being able to decompose composite numbers into their primes tucked away in memory. So let's look at an example like this where we're asked to simplify the fraction. So 45 over 81, again, we just have to figure out what is the common factor that I could rewrite each of these as, such that that common factor then divides out, and I'm left with a simplified version of the original, right? So looking at 45 and 81, I might recognize, for instance, that these are both multiples of, say, 9. So, for instance, 45 I could rewrite as 5 times 9, and 81 would be something like 9 times 9. So, listing the common factors 9, I can see that they will cancel each other out, and I'll be left with simply just 5/9 for my simplified fraction. So 5/9 and 45 out of 81, these are equivalent statements. However, 5/9 we would consider the simplified, and in fact the simplest version of this ratio. Now I may see also examples where some variable terms are included, and in this case I can basically ignore the variables. They're not going to reduce any the way that some fraction of numeric values would. So x over y doesn't really do anything when we simplify this. We can basically focus on the coefficients on their own terms. So for instance, looking at the coefficients here, 15 and 20, I still want to figure out what is a common factor between those two values that will cancel out when I go to reduce. So 15 and 20, they actually both have a common factor, in this case, of 5. And so I can rewrite the numeric statement here as, let's say, 3 times 5, again, times x. And 20y I could restate as 4 times 5 times y. Again, we see a common factor canceling here, and we're left with 3x in the numerator, 4y for my denominator. So there's my simplified fraction in this case.